Welcome back, everybody. We're again delving into the FE Fundamentals of Engineering Mathematics section. As you can see by the title, we're talking about the law of cosines today. But what you really need to get in the habit of doing, especially for the math section of the exam, is being able to read the problems and categorize what type of problem it is. So obviously on the exam, you're not going to know that it's law of cosines by reading it. But if we look at this problem, we see that it's telling us that we have three circles of various radiuses that are tangent to one another. So if we draw this out very loosely, we'll have one large circle here, another circle here, another circle here, pretend they're tangent to one another, and there's a triangle formed by their three center points. So if we look at a better diagram of this, we have it shown here. The largest circle has a radius of 440 meters, the smaller one 260, and the smallest 220. And we can see that we have a triangle formed by their centers. So if we take a look at that red triangle, we see that they're asking us to find all of the internal angles of that triangle. So we can label these. We can call this A, B, C. And we obviously have our side lengths, right? We have the radius here. We know this is 440. This one's 220. So the side length of the triangle here is going to be 660 meters. And then again, 440 and 260. So this one will be 700 meters. And then the two smaller circles, 220 and 260. So this will be 480 meters. So we have a triangle here where we have three side lengths and we need to find three internal angles. This isn't necessarily a right triangle, but we can remember that the law of sines and cosines work for all triangles, not just right triangles, and they're relationships that help us to solve for either angles or side lengths based on our knowledge of the opposite. So if we look here, this is from our reference manual directly. We have our law of sines, which shows that there's a relationship between an angle, right, capital letter representing an angle, and a side length, lowercase letter, and another angle and a side length. So if we have either two angles or two side lengths and one of the other, and we're trying to solve for an unknown, we can use that. Here, that's not the case. We don't have any angles. We only have side lengths. So in this case, we want to use the law of cosines, which is what we're going to do here. And we could see, again, we use capital letters for angles. So if you have one angle and three side lengths, lowercase letters, then you can solve for each other. And that's what we want to do here. So we said on our last slide that we were going to call this A, this B, and this C. So if that's the case, we want to make sure that we keep our lettering consistent. So if this is angle A, the side opposite of it is side A, angle C, the side opposite is side C, and angle B, the side opposite is side B. So now we can run this problem through 3 times, each for one angle that we're trying to solve for. So first we'll solve for angle A, then angle B, then angle C. So if we start with angle A, again we said that this was angle A, side B, side C, side A. So if we follow this equation, A squared, 700 meters squared, equals side B squared, 800 meters squared, plus side C squared, minus 2 times 480 times 660 cosine A. So obviously we're going to be solving for A here. So if we do 700 squared, it's going to be 4.9 times 10 to the 1, 2, 3, 4, 5, 10 to the 5th. 480 squared is going to give us 2.304 times 10 to the 5th. 660 squared is going to give us 4.356 times 10 to the 5th. 2 times 480 times 660 will be a minus 6.336 times 10 to the fifth cosine A. So we're going to subtract out these two terms from the first term here. So 4.9 times 10 to the fifth minus 2.304 times 10 to the fifth minus 4.356 times 10 to the fifth. And that'll give us negative 1.76 times 10 to the fifth equals negative 6.336 times 10 to the fifth cosine A. Obviously, we'll do our division, and we'll get cosine A equals 0.27. So if we take our inverse cosine, we will get A equals 73.87 degrees. So we've got our first angle. So now we would just repeat the process for our other two sides to solve for angle B and for angle C. Obviously, we have two side lengths and now we have a single angle, so if we wanted to, we could use law of sine to solve for the other two instead of law of cosine. The only trick there is that you're basing everything on this first angle calculation, so if you did that calculation incorrectly, it will carry through to the other angles. So I won't go through the process of completing the other two angles, but if we do it, we'll get B equals 41.2 degrees and C equals about 64.92 degrees. So again, B is calculated, this is side B, as 480 squared equals 660 squared plus 700 squared minus 2 times 660 times 700 cosine B. And C is calculated as, again, this is C, 660 squared equals 480 squared plus 700 squared minus 2 times 480 times 700 cosine C. So you could solve for these, and then obviously at the end, the sum of these three, since it's a triangle, should equal 180 degrees. So if we take a look at this, 64 plus 41, that's going to equal about 105 and 73. Added to that, it's going to be around 180. We did some rounding here, so it's not going to be an exact, but it should be around 180. And if you keep all the computation in your calculator, you should get 180 exactly. Enjoying these videos? Follow the links in the description below to find out how you could reach out for personal tutoring, like and subscribe to get notified when new videos drop, and comment with suggestions for future topics.